Let's think of training a neural network as similar to training a kid to cross the street. So you wouldn't just let the kid cross the street on their own. Usually what you do is you'd go to some streets around your house that you knew and hold their hand as they cross the street and show them the red light, the green light, and things like that. And you'd try to show them all kinds of different situations, streets with stop signs, maybe some streets without crosswalks, maybe some busy streets and some quiet streets. You just try to come up with every example that you can to train them, to teach them how to cross the street. And then probably before you let them on their own to cross the street all by themselves, you would want to test them a little bit. So you'd take them to some new streets that you haven't seen, and you'd just stand on the corner and watch them cross the street on their own. And you'd probably do that a couple times before you felt confident that the kid could safely cross the street anywhere. Training a neural network is pretty much the same thing. We show it a whole bunch of examples of something that we want it to learn and train it, and then we try it out on a few more examples and see how it's doing before we let it go in the real world. One of the most famous data sets that we use for this is called the iris data set. It has 150 examples in it of 3 different species of iris. And for each example, there are 4 measurements: the sepal length, sepal width, petal length, and petal width, and the species is then listed. So the idea is that if you take a look at these 4 characteristics, maybe you can categorize this flower without knowing what it is into one of these 3 species that's listed. So if we scroll down, we see we have iris setosa. We'll make this a little bigger, and we have iris versicolor, and then we have iris virginica at the end. So this is the data set that we're going to use right now. We do want to clean it up a little bit, so I brought it into Excel. The computer doesn't find much value in these words for the species. It's much more comfortable if we use numbers or integers. So we're going to replace iris setosa with maybe 0. So I'm going to go up to find and replace. And I'm going to replace, every time I see iris setosa, I'm going to replace that with 0. Okay. And we're going to do the same thing with iris versicolor. But we're going to replace that one with 1. Oops, I think it's versicolor. And then finally, iris virginica, we will replace with 2. Okay. And I've done a little fancy footwork on the side here to try to turn these numbers here into a list. So you can see I've concatenated a whole bunch of characters together with information from this list. At the end, I take all the items and concatenate them together into something that's starting to look like a Python list. I'm going to copy that. So what we did in Excel was a little bit of data pre-processing, and now I'm going to copy that list over here and prepend it with iris equals. So we're going to make a list called iris out of all this data. At the end, I know I have a trailing comma, so I'm going to need to get rid of that. Push enter. So now we have this list. It's actually a list of lists called iris. And if we look at the first one, we can see one example from our data set. We can look at any examples. We can look at the length of iris, should be 150. It's a good thing to check. And then we'd like to take this data set and split it into 2 pieces. We want our examples, which are the 4 characteristics, and the labels, which are the type of iris, to be actually in separate lists. So we're going to say examples. Actually, we'll just call it X equals. We want a list. And the X values are going to be the first 4 values. iris in iris. Okay. So now if we list X, we see that we have just the first four values. So this was a list comprehension. A little confusing because I use the same name twice here. So we're saying for each example in iris, we just want to include the first 4 elements in our new list. And then we want a Y value that's going to include just the last element. So I can do iris -1 for iris in iris. If we print Y, we should have all zeros, but if we scroll over a little, we see 1s and 2s. So now we have 2 separate lists, but they're really parallel because if we look at the first item of X, it corresponds with the label in Y. And that's important because as we go through and present these examples to our neural network, we want to make sure we remember we need these to stay in the right order. And that's going to be a little tricky because we're actually going to randomize our data set. We'll do that in a second. The next thing we need to do is split our iris objects into a training set and a testing set. And we want to do that randomly. Maybe we want 70% of these items to be in our training set and 30% to be in our testing set. You can see why we need to do that randomly. If we just took the first 70% of these examples, they would all be the species 0 and 1, and the last, maybe a couple 2s, the last 30% in our testing set would be all of species type 2. That's a problem because if our neural network has never seen or seen very few examples of species type 2, and then we ask it in our testing set to identify only species type 2, that's going to be very tough for the neural network. So we try to give it a really wide variety of examples, and we do that by randomizing the training set. But remember that we want to leave the X values, which are the examples, and the Y values, which we call the labels, parallel. We don't want to just randomly shuffle each list up because then they won't be matched up anymore. And the way we're going to do that is we're going to actually create sort of a shadow list of pointers to our original set. We're going to leave the original set untouched, and we're going to say like our training set is going to have indices 4, 7, and 12. So 4, 7, 12 becomes our pointers to the training set. The way we're going to do that is we're going to use a module called random. So we need to import random. The random module gives us random numbers, well, pseudo-random numbers actually, and I'll let you look up the difference. But for instance, we can say random.randint 0, 5, and we get a random number between 0 and 4. Because remember, in Python, the last number we never ever get to. So we can do this over and over again and get random numbers. Interestingly, we can say random.seed and give it a value, and because these are actually pseudo-random numbers, if I run randint a couple times, I get 4 and 2. If I seed it again with 34 and run randint a couple times, I get 4 and 2 again, which is really useful for testing because sometimes we don't really want random numbers. We want some random like numbers to show up in the same order every single time so we can make sure that we're getting the same results. And we'll use that later in this assignment. But another interesting thing that the random module does is it gives a sample of random numbers. So we're going to say random.sample from a population of, say, range 0, 10. We're going to pick 3 numbers. So this gives us 3 numbers from the range of 0 to 10, and they'll always be unique, so you'll never have the same number repeated. This is useful for us because what we really want is a random sample of numbers from 0 to 149 to serve as our indices for our training set and then our testing set. So we'll say training indices equals random sample. Remember, we have 150 examples. So we'll say 0 to 150, which will give us, range 0 to 150, which will give us the numbers from 0 to 149. And from that, we want to pick 70%, let's say 105 examples. So now if we look at the length of train indices, we have 105 samples. And they're actually just the numbers randomly chosen from 0 to 150, 105 of those numbers. So they don't actually contain our data, but we can use them to refer to our data. So if we go back to our list of examples, which we called X, and we say example 129, for instance, which is the first number that we got in our random list, we see this example. We can also find out the label corresponding to that example is of species type 2. But of course, what we do in our program, instead of hard coding a number in there, is we'd say, I want to know the example that's related to train indices 0, or our very first randomly chosen number. We also need a list of test indices, because eventually we're going to test our neural network on the remainder of the data. So we want test indices to be the numbers from 1 to 150 that are not included in this list. And unfortunately, that's not easy. If we just say test indices equals, let's say we take the list of numbers from 0 to 149 and subtract our list train indices, we find out that that's not supported for lists. We can't do a subtraction. It's obvious to us what we want to do. We want to take this list of numbers from 0 to 150 and subtract out the numbers that are already in train indices. But there's no function for that in Python. So what we'll do instead is we will turn each of these items into a set. So test indices. We want a list, not a set, so we're going to typecast that into a list. But we're going to turn range into a set. Range 0 to 150. And we're going to turn our list that we already have, the train indices, also into a set. So we have the set of numbers from 0 to 149, and we have the set of numbers that we've already chosen. And those data types do actually support subtraction in the way that we really want to see it. In other words, taking this list of numbers from 0 to 149 and removing the numbers that are already in train indices. So now if we look at test indices, hopefully the numbers that show up here are the ones that were not already in this list. And you can kind of spot check it, but another way to be convinced of that, we knew the length of train indices was 105, the length of test indices had better be 45, which it is. That's great. Excellent. So now we have a list of indices for our training set that points back to our data set, and a list of other indices, not included in that, that points to our testing set. And we want to use these over and over and over again. So when we're training our neural network, we're going to present these examples many, maybe 10,000, 20,000 times to our neural network. So we're actually going to create another shadow pool here that we're going to call train pool. And we're going to copy the train indices into the train pool. And that's the number we're going to use for what we call one epoch, when we take the examples and we go through our 105 training examples and show them to the neural network once. It could be in order, it could be in random order, but we're going to show all 105 to them, to the neural network, and then we're going to reset and do it again. But we're going to use a different kind of container for this called a DQ that we talked about in the lectures. So we want to import collections so we can have that DQ object. And we're going to create train pool as a DQ from our training indices. Okay. And it looks pretty much the same. It looks like a list of numbers. It does say DQ in the front. But the difference is now we can pop off the very first number. So instead of just accessing the number and then deleting it from the queue, remember we only want to use it once for each epoch, we will actually say train pool dot pop left, because we want the number on the left, the very first number. And it gives us the number 129, but then if we look at train pool again, we notice the number 129 is gone. So it actually popped off the number on the left, 129, and gave it to us all in one function here. And then what's left is the remainder of train pool. So we can do that again and again and again until our training pool is exhausted. There's one last little bit that you'll need for your toolbox in order to complete assignments 1 and 2. We don't always want to show our samples in the same order to the neural net. Sometimes learning can be better accomplished by showing things in a different order with every epoch. So the problem is if we say train pool equals collections dot DQ from our train indices, and then we print out train pool, and then we pop a few of those, and another one, and then we go back and refresh our train pool. We see that all of our samples are in the same order again. We might not like that. So what we'll do is we will create a train indices temp list, and we'll use another method from the random module called shuffle, and we'll shuffle train indices temp. And notice that this doesn't have a return value. It's actually shuffling train indices temp in place, which is why we didn't shuffle our original train indices. We might sometimes want that to remain in order. And then we can set train pool equal to collections DQ train indices temp. And we see that we get the same pool, but in a different order. So enjoy these assignments. They're tough, but I think I've given you all the little bits that you need. You just have to figure out how to put them together to complete the assignments, and I'll see you in the forums.